Now let's take a more detailed look to our experiment. We saw what we have. What? We have generator 1 and generator 2 producing N S1. Both signals were close to harmonic. We can say what S1 was some max cosinus omega 1t and was some cosinus t. We got a sum of such signals. What we received, what we got here. Let's try to understand. At first, let me be delta omega SA. If we are close, let's say is my when let's say frequencies are relatively close. It allows us to do something like this. Let's say we have a complex plane and, okay, let it be, vector producing our first voltage. We can imagine what complex rotates with speed omega 1. It will allow us to freeze the U1 first. We can understand what rotates relative to the first voltage with the speed of delta omega. Resulting voltage will have a very complex nature. On the one hand, let's say both vectors are in line. It gives us one line. On the other hand, it is possible moment when both vectors are directly opposite. It will give us something like 0. As we saw, result is field with high frequency. Sorry, I need we definitely will see something like this. Sorry, we have opposite line too. We have an opposite line too. summary, we need some amplitude, what we got here. If angle between, let me take another color, let's say at the moment this angle is beta. This angle is variable. In fact, it's a time function, but let's see. What about this angle? The maximum amplitude possible to our signal can be determined using cosine theorem. Possible this yellow voltage U sum, this yellow voltage U sum, can be determined from cosine theorem as a square root from first voltage square plus second voltage square minus 2 cosine no our angle beta. But beta itself is nothing else than P minus delta omega multiplied by T, because this vector rotates with the speed delta omega. That's why beta can be marked as minus cosine omega T. And our sum of voltage will be square 1 square plus U2 square plus 2 U1 cosine, sorry, I need a space, here we have omega and time, all equal U1 square root 1 plus U second voltage square relative to first voltage square plus first voltage cosine delta omega T. It's an iteration for border line. We have, let's say, two borders filled with high frequency oscillation. This border line is defined by this equation. It depends on relation between second and voltage. The border line, if it's 1, it's sharp angle. Something like 1/10 will give us very nice cosine. side. The bigger this relation, the higher is second voltage relative to the first one, the deeper is this angle. Now let's speak what we got about spectrum. What's the spectrum of product? We can take two different cases. In the one case, let's say is much smaller than the second one. It will give us vectorial diagram something like this. Second, very small first voltage, rounding, making a very small circle. This will mean what omega is very close to omega 2, and summary voltage is approximately multiple 1 star 1 cosinus, meaning what we can approximately write, it's 1 plus against cosinus. We will see a harmonic signal as output with a frequency very close to our difference frequency. In fact, if we speak in terms of signal theory, we will have amplitude modulated signal with harmonic modulation. It's very easy to understand that it will have one central frequency and two smaller, not less than a half of central, not greater than half of central, side frequency. But what if in this case we have virtual harmonic output? In fact, output will be very close to cosine. But what if voltages are close? What if they are near? In that case, we will have something like this. First, second, something like this. This will be our back, and this will be our summer voltage. Since these two are very close, this small angle will be and resulting frequency of this vector can be written as plus delta omega in half This mean in half. So if both voltage and both signal are equal, resulting frequency is nothing less than half of the sum. Average frequency is the average. And output voltage of our system, if we can call it output voltage, will be 2 cosinus omega in half of 2 cosinus omega 1 omega in half. And changes from 0 to the double voltage. Change from 0 to double. If we apply such voltage to any nonlinearity, it may be nonlinear resistance or diode, or take an absolute value anyway, resulting output will contain, let's say, in most easy, we can do something like this. Here, voltage will contain DC component and 2 signals. One and most strong will be frequency difference cosine. We will see, and we saw, voltage what is in fact cosine of frequency difference. It also may contain some original signal, in our case 500 kilohertz, and in some small quantity some 1 megahertz. This all will be taken by this capacitor, and we will, if we add another one here, we will have nothing else than cosine in half multiplied by time. Yes, time should be there. It's what we will get, and it's what we saw.